In our class today, we're going to talk about the control structure of the Python. So the instruction within a programming language that is saved to a file is technically written as a code. So that is, the code is a literal text that makes up a program. So generally, a program is a collection of statements. So a statement is a unit of code that the interpreter can execute, like in the flowchart diagram below. So after the program executes one statement, it will move to the next one and execute it like the following one. So the execution flow of the program can be thought of as steps, so one step following after another, and thus a program contains a sequence of statements. So if there is more than one statement in a sequence of statements, the statements are executed in the order they appear, one at a time. So usually each statement of a sequence is usually put on its own line. So consider these three statements below. Like the first one is print 1, and the second line is assign 2 to the x variable, and then print this x. So when you run this statement in Python script line by line, it will produce the output like the first line is the output of 1, and the second line is the output of 2. So notice the assignment statement, which is the second line, produce no output. Okay, so only the print give you the output on the screen. We almost always need the ability to check conditions and change the behavior of a program accordingly. So a compound statement are employed accordingly for this means and are required to be typed on more than one line. So if the statement and the if statement and its variations, like the for statement and the while statement, are all compound statements. When using a compound statement, the line that ends in a column is the header line. So the header specifies when to execute the indented statement that comes after. Any number of statements can be written as the indented block, but there must always be at least one statement. Okay, so you cannot just put an empty within this compound statement. The simplest form of such a conditional compound statement is the if statement. We have already used if to say do this block of code provided that a certain condition holds. So this is the basic format of this if statement. Okay, so any expression can be used as a condition here, and it will be checked by Python to determine if it is true or false. There is a typo. So there is no limit on the number of statements that can appear in the body of the compound statement. However, for a compound statement to exit, there must be at least one statement in the body. In Python, the path statement does pretty much nothing at all and acts as a placeholder for the code you have yet to write. So the below codes means you can write a compound statement where its body has no meaningful statement that are part of the execution of the program until you are ready to write the block of the code. And here you can use this path to be the placeholder provided in the structure of this if statement. But actually the path does nothing in here. It's just like a placeholder to make sure in this if statement it is not empty. So just as an expression such as 2 plus 1 evaluates to the integer 5, the logical expression 2 smaller than 3 always evaluated to be true. In any program that follows good principles of software design, the condition is usually one that is built from using comparative operators and logical operators. For example, x plus 1 larger than y, when the condition is reached, it is considered true only for the particular event when x plus 1 is greater than the value of y. Comparison operators are some specific operators that compare two or more expressions and return a Boolean value of true or false after they are evaluated. The literal word true and false exist in Python as special values as a result of a Boolean expression. So a Boolean expression will always evaluate as one of these two Boolean states, either true or false. There is no third value. So true and false are special values classified as bool when you check their type of value by using the type command we introduced before. Actually, they're not string. They are the bool values. This is not the strings. So each keyword must be typed as shown in here. So you need to use the capital T and capital F when you type true and false, and are never enclosed in quotes. Okay. When the if statement is reached in the program, the condition that is specified in the statement is checked. If the condition is true, the indented block is executed, and when it is false, the indented block is ignored. Okay. So in either case, whatever statement follows next after the if statement are executed afterwards. So in there, if the condition here is true, then it will execute this indented block, and and then after executing the indented block, it will go to the next statement. And if it is not true, if it is false, it will directly go to the next statement. Okay. So the operand of logic operators should be Boolean expressions. However, nearly all values count as true in Python. For example, any non-zero number and non-empty string is interpreted as true. We can use values as conditions other than expressions we described with comparison operators. If we write and execute the code, such as if 17 and with a column and print hello, then the hello will be printed because 17 is considered as true. So the flexibility of what is true value may be useful yet sometimes confusing. It is a good idea to avoid using values as Boolean expression until you are sure of what the condition should be for a compound statement for it to be true. A few values are considered as false in Python, but other than the capital F false. This include like among other values, the integer 0 and the empty string, the empty list, etc. And we call in mathematics that we generally use the operators such as greater than, smaller than, equal to compare the numeric expression such as 10 is smaller than is equal or smaller than 9 plus 1. Okay. However, the symbol equal or smaller is not present as a character on the keyboard. So in Python, in Python, the pair of symbols smaller than and equal is used to represent this symbol instead. And likewise for the greater and equal to, this greater than and equal is typed to represent it. So similar notation used for this equal and divide operator, but the character used for this operator is not divide. So here is a list of the comparison operations worked for any kind of Python-specific evaluation, such as numeric evaluation, where the operand appears to be type float or int when evaluated, and string evaluation, or some string-like evaluation, where the operand made up of non-digital characters. Okay, so this is a table the two operators use to use a logical operator not to expand upon their original operation for comparison. To describe a condition with specific operand boundaries, such as a numeric expression, you'll see appropriate operators at least 2 times with the bounding operands specified. For example, what if the expression like 0 smaller than x smaller than 20 is the condition for the compound statement. It is true when the value is between the number 0 and 20, so the expression is otherwise false when the value of the variable is either below the, smaller than 0 or greater than 20. Okay? So the most common error among new programmers is to use a single equal sign instead of the comparison operator when describing a condition. You must consistently remind yourself that typing equal once means it is an operator for variable assignment. So that is, we assign the value of x equals to y. Okay? Only when it is typed twice by double equal signs, and that is expression can be considered as an operand for the condition. So in this case, if x double equals to y, means compare the value of x to the value of y to see if it is equal to each other. When you look up words in a dictionary or file names, you used an implicit English rule for ordering strings, usually called dictionary order, associating each letter from capital A to capital Z with the number 1 to 0 when ordering is based on the letters. So for two words W and V, the character positioning rules are as follows. If the first letter of W is smaller than first letter of V, then W is less than V. If the first n number of letters of W and V are the same, but the n plus ones of W is smaller than the corresponding value of V, then W is smaller than V. If W is a prefix of V, then the W is smaller than V. And if these two words are identical, then we can make the W equals to V. Okay. So generally, the characters are ordered by their ASCII2 values. And in Unix, you can see the ASCII2 table by looking up the main page of ASCII2. Although the rules of words remain the same, the sort order for ASCII2 characters is familiar. So when the strings are compared in the expression below, the operands must be typed as strings for evaluation before the comparison proceeds. Okay. So comparison of two sequences starts with the first element from each sequence, like the examples below. So when the first element of each sequence are equivalent to each other, the comparison moves on the next element in each, and so on, until a difference of two elements at the same index value is found. So subsequent elements that follow the discovery of the differences are not considered, even when those pairs of elements are vastly different. So to comparison for variables x and y, such as x is not y and x not in y, use the logical operator keyword not to expand upon the comparison operators. So in the first expression, the is keyword is usually compares the literal object value of x and y, not the variable names. And in the second expression, the in words generally applied to any kind of collection that the variable y represents, such as a string, a list, a tuple, or a dictionary, where the value of x is checked to be one of item within that collection. Parentheses are not necessary when an expression, such as a condition, is all tapped on one line for a compound statement. But we can enclose long condition expression in parentheses, so we can continue it on a subsequent line without confusing the interpreter. You can try the example after the class. Okay. A second form of the if statement exists in which there are two blocks of code and the condition determines which block of code gets executed. As usual, it starts out with a condition followed by an indented block of statement to carry out when the condition holds. Okay, so Now it is also have a else part with an alternative block of identity statements carried out if the condition does not hold. With an if-else statement, one of the two blocks is certain to be executed, and the if block if the condition is satisfied, and the else block otherwise. Since the condition must either be true or false, exactly one of the alternative blocks of code will be executed when the condition is evaluated. Regardless of which branch is followed, the next statement in the program proceeds after one of the blocks will be executed. Okay. So you can try to run this example after the class. And the alternatives are often called branches because they are like the branch in the flow of execution. Sometimes there are more than two possibilities of conditions to consider, and we need more than two branches. So when we can use an extended version of if-else called elif-else statement. Okay, so this statement is handy when we want to choose between more than two possibilities. We can specify any number of conditions as we like without using deeply nested if-else statement. And technically, there is no limit on the number of elif statement, so we can specify any number of branches. Below is how code would generally load without elif. Say if we do not use this elif statement, we should use the if-else a lot of times, multiple times. However, and with the deeper indented statement. So this version also makes it easy to see the elif is a kind of contraction of the Python keyword else and if. Okay, and the flow of execution is often called a chained condition because each condition is checked in order. So when the first condition is false, then the next one will be checked, and so on. If one of them is true, this corresponding branch executes and the statement ends. Although more than one condition can be true, only the first branch that is discovered to be so will be executed. So consider this simple program that converts the value of Fahrenheit scale temperature to the Celsius temperature. And if we execute the code and give it invalid input, it will fall with an unfriendly value error message. And we can handle this type of expected semantic error by using two compound statement keyword named try and except. So here is the basic structure of this try and except. And the Python interpreter will begin with executing the sequence of statements in the try block. And when an exception occurs in the try block, the Python jumps out that block and executes the sequence of statement in the alternative except block instead. So, or when all goes well in the try block, it will skip the except block. So the execution of try except is similar to if-else statement, but designed for error. So when the exception is discovered, you want some statements to be executed, such as a warning, or to continue a different sequence of actions based on the error that your program might discover. Either way, the following statement proceeds after one branch is executed. The idea of try and except is that you know that some sequence of instructions may lead to an error that can be avoided. Unlike conditional statement, try does not require a condition. Instead, the except line for the program accepts errors as condition to catch it. For example, the above exception could have been written as except value error. And in general, catching an exception gives you a chance to fix the problem, or try again, or at least end the program gracefully. because we don't want to make the program run forever, right? When using try except, any number of exception blocks can be included for various type of errors that may arise during the try block. When a specific type of error is found, the alternative block for that particular exception is executed.